Hello and welcome back to my channel. In this video, I am going to create a Oldham coupling and study its mechanism, how it works. The Oldham coupling basically is a mechanism used to transmit the torque between the two parallel but misaligned shafts. Here you can see the misalignment in these two shafts. You can see the span, that is distance between these two axes, central axis of the shaft. So to transfer the torque in the misaligned shaft, we need the Oldham coupling. We will create each and every parts. These two are the base for the reference purpose. These are the two shafts, and this one is a flange. There are two flanges with a hole for the pin lock, and this one is a central disc to connect and transfer the torque from one shaft to other. Let's create each and every part, and at the end we will study the motion also. Now let's start the part drawing and the assembly. First part is the disc, that is middle disc. Let's create it. Go to right plane and sketch a circle here. From origin point, dimension this 70 mm. Go to feature and extrude it from mid plane. Provide 6 mm thickness. Now go to this face and sketch a center rectangle here. Dimension it. This is 10 mm. Okay, select this face and convert entities to create a lines here. Now select trim entities. Trim these two and trim these also. Same thing here. Now sketch is ready. Go to feature and extrude it up to 6 mm. This time blind. Click OK. Repeat the process but in the perpendicular direction. Just dimension it same 10 mm. Select this face and convert entities. You will find the edges. Now trim entities. Trim these both lines, both curves, and these unwanted lines. Click OK. Go to feature and extrude it. Blind 6 mm. Click OK. This is a simple disc. You can provide the fillets here also, but let it be. Select a real view graphics for the better view. Select solid and provide some appearance. Let's say red. It's a decent color. Now save it in a file. Oldham coupling. Now name it as a disk. Now second part is flange. Let's create a flange. Go to right plane and sketch a circle again here. Provide the dimension 70, same as the central discs. Now go to feature and extrude it up to 12 mm. Click OK. Now go to this face, normal. Select a circle and draw the two circles here. Dimension them. The central one will be 20 and this will be 40. Now go to feature and extrude this 20 mm. Click OK. Now Actually, you need a through hole. Select a circle here, dimension is 20. Go to feature and extrude cut to through hole. Click OK. Now go to this face normal. Again draw a center rectangle here. Now dimension this. Again this will be 10. Now extrude cut. Extrude cut blind. The extrude cut will be 6 mm. Click OK. Now flange is almost ready. Here we will do one thing. Go to front plane normal and sketch a circle here. Provide the smart dimension 5 mm. 4 mm is enough for lock pin. Normal. Go to feature and extrude cut. Now provide that dimension 25. This will cross it. Cross the thickness. Click OK. Now this one is for the lock pin. This is a left side flange. The right side flange will be same, but the cutting will be in the perpendicular direction. So we don't need this. We will copy it and use it as a right. We'll rotate and use it as a right flange. If you want to give the appearance here, go to appearance and select pink or black is also okay. This look good. Go to feature and save it. Oldham coupling flange. Rename it as a flange. Okay. Now we need a shaft. Simple shaft. Just sketch a circle of diameter 20 because the hole in the flange is 20. Go to feature and extrude it up to 50 millimeter. Click OK. Now give appearance. Select any appearance. Click OK. Now save it as a shaft. Now we all have all parts. File save as a desktop Solidworks and shaft. Saved. Now let's create a pin. Go to any plane. Sketch a circle. The pin should be tapered, but we will focus in the Oldham working principle. So just create a cylindrical pin. provide a 4 mm diameter. Go to feature and extrude up to 19 mm or 29 mm. Okay, save it as a pin. Okay, now we are going to create a base here, base for the reference purpose only. So go to right plane and draw a shape here. Just draw a line. Now select the center point of this line and this origin point to make coincidence. Dimension this line 70 mm and draw a shape. Now dimension it. From this height will be 25 and from this point to this bottom point will be 80 only. Okay, draw a center line here. Make sure it's a vertical. Now define the upper length. This one will be 15. Okay, now mirror entities. The entities to mirror are these two lines and mirror about center. Just click OK, take a line command and close this sketch. Go to feature and extrude it. You can choose any plane, mid plane, and let's say it's a 12 mm. Click OK. Now go to this face normal. This one is just a shape only for the support. Smart dimension this middle one 92 and dimension this circle 20 because the shaft diameter is 20. Click OK and extrude cut. You can provide the fillet here. Select one edge and follow the suggestions. Provide the fillet radius 2 mm. Now it looks good. Save it as a base. Click OK and save it. You can provide appearance, but click OK. Save it. Since the working principle of the Oldham coupling is for connecting the two parallel shafts whose axes are at the small distance span. That means if the two shafts are parallel, but they are in a small distance span, Then we need this coupling. So we want to change the height here, the height of the hole in the base. So copy this and rename it as a base in the right side. Base right. Open it and we will edit this. So go to edit the sketch. Now we will reduce the height only. So go to this sketch and edit the sketch. This time height of this cylindrical hole from the base will be, let's say, 85. Originally it was 92. Now you can see the change in the position of the hole. Save it. Now we have created all the parts. Let's assemble them. First of all, base. The first part is always fixed here. Now insert the component here. Control key and flange and shaft. Flange and shaft. Okay. Now mate. This one with cylindrical face. Okay. Now better rotate it for the perfect alignment. Select mate. Select this inner arc with this edge. Okay. Select this face. In this face, provide a distance of 6 mm only. They are perfectly aligned now. Now insert a disc here. Better rotate it for the good alignment. Okay. Now select this edge mate with the inner edge here. Okay. It still rotates. So select this face with this face. Click OK. Now it moves in the slot. Up to this, everything is perfect. Again, insert the component here. This time, no need to insert the component. We can just copy them. Press Ctrl key and drag outside. And flange also. Rotate the component. Okay. Now mate. Cylindrical face. This cylindrical face. Inner arc with the edge. Now mate this inner line with outer one. Click OK. This face with this face. Click OK. Now everything looks good. Now insert base right. You can change the height here. So let's do a one thing. Go to view and show the temporary axis. Go to front plane And now drag it down. First of all, mate one thing. The cylindrical face, clear it. This face with cylindrical face. Concentric relation. Okay. Now go to the front plane. Normal. You can drag it down to offset the axis. This axis is in this line, and we are going to provide some span here. Let's mat. Select this line. Clear it. There are unnecessary selections. Mat this axis line and this line. Provide a distance of the height between the two circles, whole circular ori in the base. The difference was 92 minus 85. This means 7 mm. 7 is okay. Now the base are in same line, and there is a span of 7 mm. You can provide any span length. Now hide the center lines axis. Define one thing, this face and this face. Provide 6 mm span. Click OK. Now everything looks good. Click OK. Go to front plane, normal. Met one thing, this one with this one. Click OK. Now go to front plane, normal. Rotate it. Now you can transfer the torque or the power in the different spans of the axis. The axis of this shaft and this shaft are different in a parallel position. Now let's create a motion study here. Motor. Select the face, this one. Let's say RPM is 40. Okay. Frame rate better 25. Click OK. Drag it to the 10-second. Calculate. Is calculating. Okay, then now you can drag down and play it. That looks perfect. Let's do one thing. We haven't assembled the pin with this flange, so select this shaft and this flange. and provide lock. Same in this side, this shaft and flange to provide lock. Save it as an assembly. Now calculate. Now shaft is rotating. Now this much in the Oldham coupling. Thank you for your time. This is the beautiful mechanism, and we have created in the SolidWorks. Please subscribe our channel and share it with others. Thank you very much.